Naming chemical compounds has been happening for hundreds, if not thousands of years. But what we've realized is that with so many different names for different compounds, it would be really nice if we could have kind of a system of naming different compounds that everyone knew how to use. And that is where the International Union of Pure and Applied Chemistry, UPAC, came in and started standardizing how we name a variety of different types of compounds. So we'll be learning how to use the UPAC naming system for a variety of different compounds. We'll be using this for binary compounds where there's only two elements. So for example, sodium chloride or carbon dioxide. For polyatomic compounds, so where there's more than just the two atoms in the compounds, for example, when you're looking at what seashells are made out of, or marble, calcium carbonate, that has calcium, carbon, and oxygen all in one compound, as well as for acids. We're going to focus on learning the chemical names and the chemical formulas for different compounds. Let's start off with working on binary compounds and how we name them and how we write out their chemical formula. Now, in binary compounds, we have either ionic compounds or covalent compounds. We started to talk about ionic compounds where we have the ions, we have a metal ion and a non-metal ion coming together. So a cation and an anion coming together to make a compound. Classic example is sodium ions, chlorine, the chloride ion coming together and forming sodium chloride. And then for covalent compounds, we aren't dealing with a transfer of electrons. We're going to be dealing with a sharing of electrons between nonmetals. So we'll first start off with ionic compounds, of which there are two different types. The two different types for ionic compounds that we have are type 1 and type 2. Now, for type 1, an example would be that sodium chloride, for example. But type 2, perhaps maybe ferrous oxide. How do we determine the difference between a type 1 and type 2? How do we figure out if our compound that we're looking at needs to be named using the type 1 system or the type 2 system? Have a look at the metal ion, the cation, or whichever comes first, right? In the naming or in the chemical formula, the metal cation always comes first. So have a look at that. And then you can check the periodic table. So find that metal on the periodic table. And if it just has one charge on our periodic table of ions, then it is going to be classified using type 1. However, if you see that there's, in the middle of the periodic table and the transition metals especially, there's a lot of different elements that have more than one charge. These are going to be classified under type 2 compounds. A type 1 compound is going to include a metal that only has one oxidation number, which we can also call charge, such as the members that you find in group 1, group 2, on that left-hand side of the periodic table, also group 3. Now, group 2 are the metals that have more than one possible oxidation number or charge, and some of those might be the transition metals, such as iron has two different charges associated. It could be either a 2+ or a 3+. Naming type 1 compounds, the cation is always going to be named first and the anion second. Now, for the cation, you just take the name of the element. It's not going to be changed from that. So if it is sodium, it's going to be sodium. If it was a magnesium ion, then you use just magnesium. Where we get a little bit of a change is in the ending of the name of the anion. The anion is the nonmetal, so from the right-hand side of the periodic table, and you take the root of the name of the element and end it with IDE, ide. So chlorine turns into a chloride ion. Nitrogen turns into a nitride ion. Oxygen into an oxide ion. So you can have a look at your periodic table of ions and you can actually see those words written in there. You then just combine the two pieces together. Combine the metal name and then the anion with the ide at the end together. You leave one space in between, and you don't capitalize the second. Now, how does naming type 2 compounds differ from naming type 1 compounds? Well, we have to include that charge, that oxidation state, into the name, so we know which iron we're talking about, for example. It's the same nomenclature for type 1 in that we say the metal name, just to start off, and the anion piece is going to be the same at the end. You use the "ide" part. The only difference here is that we're going to include that oxidation state in parentheses, in brackets, in between the name of the metal and the anion. So the cation and the anion, you'll have these brackets indicating the oxidation state of the metal. I just want to repeat that this is the UPAC naming system. There is also an older style naming system that you'll also have to know, but let's first focus on that UPAC naming system. When we're writing out the number of the oxidation state, we're going to use Roman numerals for this. So 1 is going to be indicated with a capital I, 2, 2 I's, 3, 3 I's, 4 is going to look like IV, so 1 before 5. The V is then the 5, and if you had a oxidation state of 6, then you're going to have the V and then the I, 1 after 5. Now, to determine which oxidation state was in this compound, you have to look at what the subscripts are for in your chemical formula. Sometimes looking at the chemical formula is easy to, and you can easily determine the oxidation state of the metal. Sometimes it's not so easy. In the case of iron chloride, so iron chloride, well, I would have to include include the Roman numerals. Well, if I have FeCl2, well, the 2 subscript from the chlorine, that 2 must have come from to balance out somehow, right? If chlorine has a charge of -1 and we need 2 of them to make the molecule neutral, then it must mean that the charge coming from the iron atom must have been 2. So we can determine that, okay, this is actually iron 2 chloride. If we saw FeCl3, then it must have meant that that chlorine must, to balance out the charge that the iron has, that oxidation state, then you must have had 3 of them. So a -3, to balance out a -3, you would have had a +3. So a +3 would have come from the iron 3 oxidation state. Now let's try naming a bit of a trickier compound. So I have vanadium oxide. I'm not going to say what the oxidation state is yet for you, but vanadium is the V. Oxide is, we're getting from oxygen, so the O. Now vanadium is one of the transition metals that you'll find kind of in the middle of the periodic table. So when you find this on the periodic table of ions, you'll notice it has an option of 2 different oxidation states, 2 different charges. Have either a +3 or a +5. So what we have to do is look at the subscript of the oxygen or the nonmetal to start figuring out, okay, what could the oxidation state be of our metal? Now oxygen, unlike chlorine, so chlorine only contributes kind of a -1 charge. Those in the second last row, that group 7, they're only going to contribute kind of a -1 charge. They only take one electron. However, oxygen likes taking 2 electrons. So if they like having 2 electrons each, that means that that's going to mean each oxygen that I have in this chemical formula is each going to have a -2. So if I have 5 oxygens in here, and each of them have a -2 charge associated, or they want to have that -2, then that means actually I'm trying to balance out with my vanadium -10. So my vanadium, I have 2 in my chemical formula, then the +3 charge, 2 times +3 is +6. This is not going to cancel out. This is not going to neutralize that negative charge that I have on the oxygen. Now, it isn't that these charges are coming from nowhere. Remember that these charges are coming from one to the other. So that oxygen is trying to get that negative charge from somewhere. And where is it going to take it from? It's going to take it from the vanadium. So I need to have that even, that balance, that neutral atom. So in order to get a balance to that -10, I must then have had an oxidation state of +5 on the vanadium. And so that's how we can find out the name and the oxidation state of vanadium. It would have been vanadium 5. And so our complete name in that case would be vanadium. And you have the 5 oxide. All right, folks, it's time to change things up because we know everyone loves exceptions to the rule or a completely different system that doesn't follow the nice rules that we had earlier, right? Yeah. So chemistry has been around for a little while, and there's still usage of the classic naming system that's based on the Latin as opposed to our nice UPAC named standard naming system. Classic naming system is still used for the type 2 compounds. This means that the first part, the name coming from the metal, is going to be based on the charge. So we're going to use the Latin base of that element and change the little ending of it based on what the charge is going to be, whether it's higher or lower. If it's higher, the ion with the higher charge, for example, for our vanadium example, the +5 charge, we would have the IC at the end, versus OUS would be for a lower charge. I actually shouldn't have given vanadium because I actually don't even know what the Latin name for the vanadium one is. For these ones, there's only a few of them that you really have to recognize, and they're going to be for copper, iron, and lead primarily. So CuCl, so with copper only having a charge of +1, that is the lower charge. The other charge is a +2. So with the lower charge, this means it's going to have an OUS ending on the Latin name for copper, which is cuprate. So cuprous, CuPrus chloride, versus the Cu2 plus is then going to be called cupric chloride. Iron 2 or iron 4 oxide, we're going to name this either ferrous oxide with the lower charge or ferric oxide for the higher charge. The last one you need to know is for lead. So remember lead, trying to find it on the periodic table is a little difficult because it actually starts with Pb. This comes from the plumbus. So Plumb is going to be the beginning part of our Latin name, the root for our Latin name. And the lower charge, which is going to be the 2+, is going to then be plumbus chloride. And then with a higher, if we had PbCl4, this is going to be plumbic chloride. So we're trying to name a compound. You look at it and you see it's a binary compound. You have 2 different types of atoms in it. And you've got a metal present. All right, metal present, binary compound. Your next question is going to be, does the metal form more than one cation? Are there multiple charges or oxidation states on this metal? If so, then it's going to be a type 2 compound, and you have to name it by determining the charge of the cation. Use the Roman numerals and put that in brackets in between the ion name of the cation and the anion name. Now, if the metal didn't form more than one cation, didn't have more than one charge option on the periodic table, then you use the type 1 naming system, which is use the element name for the cation and then use the root of the anion and end in IDE.